Hello, beautiful people. In this lecture, we are going to continue looking at arithmetic sequences. So this is part two um, of the previous lecture on arithmetic sequences. So we are just going to look at this question uh, where we are going to apply our knowledge of arithmetic sequences and just our general knowledge of understanding and seeing patterns. So without uh, further wasting time, we're just going to look at this question. So it reads as follows: says in each of the following tables, the pattern remains consistent. Determine the value of A. So it says determine the value of A. You can just highlight determine the value of A and B. Then give a formula relating. We need to give a formula relating Y and X. So this means that there might be some relationship between Y and X in each of these tables that we see on the whiteboard. So let's go ahead and attempt to answer the question. So they're saying in each of the following tables, the pattern remains constant. Determine the value of A and B. So first, let's try to determine the value of A. If we can try to just determine the value of A for this table, for table 1. So this is our A here, and this is our B. So if we look at this table, we notice that we have 1, 2, 3, 4, 8 for on the X values. Then we have 1, we have 3, we have 5, we have A, B. So if you look closely, you'll notice that the difference between 3 and 1 is 2, and the difference between 5 and 3 is also 2. Therefore, the difference between A and 5 here will be 2, meaning that if we add 5 and 2, we'll get that our A is equal to 7. And then our B, if we add 2 here to 7, it means that our B will be given by 9. So our B will be given by 9. Sorry. So now let's try to give a formula that relates Y and X for this table. So I would like to look at this table since it's just X and Y. I would just like to look at it in terms of a straight line. You know, the formula for a straight line is given by Y is equal to is it mx m. My pen is jamming a bit. Let me fix that. Sorry. So I can just erase that to fix this. I'm going to the wrong places. So if I want to look at this as a straight line, right? If you know the equation of a straight line, you will remember that how we find our m, which is the gradient, how we find our m, which is the gradient, how we find our m, which is the gradient, we would take a pair of coordinates. So we could take maybe this here and these ones here, and we'll then say m is equal to m would be equal to 3 minus 1 because we start by subtracting the y values over the x values. Then we'll say divide by 2 minus 1. This would be equal to 2 divided by 1, which is equal to 1. So if there's someone who's not following, so basically what we are doing here is we are saying this here is equal to changing y over change in x. So this is 2 here. Why did I write 1? Sorry. This is 2 here. This here is 2. So this means that now our y will be equal to 2x plus c. So now we can take any other pair of coordinates in here and then substitute it in this equation to find our c, and then we have our formula rather that represents the relationship between x and y. So I would like us to just take this one since it's a simple one, since it's just 1. So if we just say if our y is 1 and we have our x also being 1, this will be plus c. This will be plus c. Then we'll get 1 equal. We can just say actually I believe most of us can now see this. This is just gonna give us c equal to 1 minus 2, which will give us negative 1. So c is negative 1. This means that our equation that shows the relationship between x and y is given by y equal to 2x minus 1. So we have answered both the questions for the first table. So going into the second table, we need to find, let me use the red one first. We need to still find our a and b. So this is our a here and this is our b here. So to determine our a and b, we just have to look at the relationship here. You will notice that, okay, x is 1, 2, 3, 8 here, and then we are given x squared. So meaning we say 1 squared gives us 1, 2 squared gives us 4, 3 squared gives us 9. So what would 8 squared be? So 8 squared would be 64, I believe. If you can just check that on your calculator, it should be 64. So we can then come here and say our a is equal to 64. And then now we need to determine our b. So now if we look here closely, you'll notice that our y is 2, 6, 12. So here, all right. So here you'll notice that 2 is equal to 1 plus 1, and 6 is also equal to 2 plus 4, and 12 is equal to 3 plus 9. So our y here, okay, so our b here would be 8 plus a, which is 64. So our b will be equal to 8 plus 64. 8 plus 64 will give us 8 plus 64. That would be 672. Is it 72? Yeah, it should be 72. So our b is 72. So our B is 72. Now we want to move to the next step of giving a formula where we relate our y with x. So actually this one is a bit easier because we notice that y is given by x plus x squared, because that's how we were able to find our that's how we were able to find our b. We found our b by adding x squared to x. So this would be our answer. This is the formula where we relate y and x. So we are done with this part of the question. So I'll quickly move to the next part of the question. So yeah, this is more in arithmetic sequence type of question, but obviously some of these questions with sequences, they try to trick you and make them interesting. So you need to actually, this thing of arithmetic sequences, just like other types of sequences, your geometric sequences, your quadratic sequences, it's all a matter of pattern recognition. You need to recognize the pattern that you're given. So with this, we are given the arithmetic sequence. There's the arithmetic sequence there, and then the questions are: find a formula for the nth term. That's question 1. And question 2 then says that find the 50th term. So this is a simple uh, question. So in part 1, where we did arithmetic sequences, you might recall that, maybe if I can write, just jot down on the right side here, you might remember that we mentioned that Tn equal to A plus n minus 1 multiplied by D is the formula for the nth term of an arithmetic sequence, where A represents the first term of the sequence and D represents the constant difference throughout that sequence. So to then find the formula for the nth term, in this case here, find this formula of this nth term, this formula would be given by, Tn equal to, what is our A? You notice our A is 201 in this case. So this is 201 plus n minus 1 multiplied by the constant difference. So what is the constant difference here? The constant difference is, if we look at 197 minus 201, that should give us negative 4. And the difference here is also a negative 4. And the difference here between 189 and 193 is also a negative 4. So we have a constant difference of negative 4, so which means our D is negative 4. So I can just increase this to 4. Okay, so we can reduce this to 201. If we just get rid of the brackets, we'll have minus 4n plus 4, right? So Tn is equal to 201 plus 4 will give you 205. So we have 205 minus 4n. So this is our formula for the nth term. We have answered the question 1. So the second question now says, find the 50th term. So it then becomes simple to find the 50th term once you have determined the nth term, because all you do now is just replace n with 50, meaning that we will have t50, which means that we are looking for t50, which is given by 205 minus 4, and then where there is n on our previous answer, we substitute 50. So this would give us 205 minus 4 times 50, that is 200. So that's 200. That's 200. So the answer therefore is 205 minus 200, that gives us 5. So that's it. So um, that's how simple arithmetic sequences are. So we have come to the end of the lecture. I hope you enjoyed and found this insightful. Thank you for watching. Continue learning and growing. Keep enjoying mathematics. Let me know in the comment section how you found this, and if you'd like us to try more questions. Bye.